Friction welding is a solid-state welding process that generates heat through mechanical friction between workpieces in relative motion to one another, with the addition of a lateral force called upset to plastically displace and fuse the materials. Technically, because no melt occurs, friction welding is not actually a welding process in the traditional sense, but a forging technique. However, due to the similarities between these techniques and traditional welding, the term has become common. Friction welding is used with metals and thermoplastics in a wide variety of aviation and automotive applications. Benefits: the combination of fast joining times, and direct heat input at the weld interface, yields relatively small heat-affected zones. Friction welding techniques are generally melt-free, which avoids grain growth in engineered materials, such as high-strength heat-treated steels. Another advantage is that the motion tends to clean the surface between the materials being welded, which means they can be joined with less preparation. During the welding process, depending on the method being used, small pieces of the plastic or metal will be forced out of the working mass. It is believed that the flash carries away debris and dirt. Another advantage of friction welding is that it allows dissimilar materials to be joined. This is particularly useful in aerospace, where it is used to join lightweight aluminum stock to high-strength steels. Normally the wide difference in melting points of the two materials would make it impossible to weld using traditional techniques, and would require some sort of mechanical connection. Friction welding provides a full-strength bond with no additional weight. Other common uses for these sorts of bi-metal joints is in the nuclear industry, where copper-steel joints are common in the reactor cooling systems. And in the transport of cryogenic fluids, where friction welding has been used to join aluminum alloys to stainless steels and high-nickel alloy materials for cryogenic fluid piping and containment vessels. Friction welding is also used with thermoplastics, which act in a fashion analogous to metals under heat and pressure. The heat and pressure used on these materials is much lower than metals, but the technique can be used to join metals to plastics with the metal interface being machined. For instance, the technique can be used to join eyeglass frames to the pins in their hinges. The lower energies and pressures used allows for a wider variety of techniques to be used. History: friction welding was first developed in the Soviet Union, with first experiments taking place in 1956. The American companies Caterpillar, Rockwell International, and American Manufacturing Foundry all developed machines for this process. Patents were also issued throughout Europe and the former Soviet Union. The most extensive historical records are kept with the American Welding Society. Metal techniques. Spin welding Spin welding systems consist of two chucks for holding the materials to be welded, one of which is fixed and the other rotating. Before welding, one of the workpieces is attached to the rotating chuck along with a flywheel of a given weight. The piece is then spun up to a high rate of rotation to store the required energy in the flywheel. Once spinning at the proper speed, the motor is removed and the piece is forced together under pressure. The force is kept on the pieces after the spinning stops to allow the weld to set. This technique is also known as inertia welding, rotational welding or inertial friction welding. Linear friction welding Linear friction welding is similar to spin welding except that the moving chuck oscillates laterally instead of spinning. The speeds are much lower in general, which requires the pieces to be kept under pressure at all times. This also requires the parts to have a high shear strength. Linear friction welding requires more complex machinery than spin welding, but has the advantage that parts of any shape can be joined, as opposed to parts with a circular meeting point. Another advantage is that in most instances quality of joint is better than that obtained using rotating technique. Friction surfacing Friction surfacing is a process derived from friction welding where a coating material is applied to a substrate. A rod composed of the coating material is rotated under pressure, generating a plasticized layer in the rod at the interface with the substrate. By moving a substrate across the face of the rotating rod, a plasticized layer is deposited between 0.2 to 2.5 mm thick depending on metro diameter and coating material. Thermoplastic techniques. Linear vibration welding In linear vibration welding, the materials are placed in contact and put under pressure. An external vibration force is then applied to slip the pieces relative to each other, perpendicular to the pressure being applied. The parts are vibrated through a relatively small displacement known as the amplitude, typically between 1.0 and 1.8 mm, for a frequency of vibration of 200 Hz, or 4 mm at 100 Hz, in the plane of the joint. This technique is widely used in the automotive industry, among others. A minor modification is angular friction welding, which vibrates the materials by torquing them through a small angle. Orbital friction welding. Orbital friction welding is similar to spin welding, but uses a more complex machine to produce an orbital motion in which the moving part rotates in a small circle, much smaller than the size of the joint as a whole. Seizure resistance. Friction welding may unintentionally occur at sliding surfaces like bearings. This happens in particular if the lubricating oil film between sliding surfaces becomes thinner than the surface roughness, which may be the case for low speed, low temperature, oil starvation, excessive clearance, low viscosity of the oil, high roughness of the surfaces. The seizure resistance is the ability of a material to resist friction welding. It is a fundamental property of bearing surfaces and in general of sliding surfaces under load. See also, friction stir welding. References. External links, Forge Tech, Incorporated. Friction forge bonding, friction welding at TWI.